when we first talked about multiple cash flows and we calculated the future value of a series of multiple cash flows, the future value was one period after the last cash flow. When we're dealing with multiple cash flows and treating them individually, we can calculate the future value at any point in time. However, the shortcut formula that we are about to use gives us the future value of a series of identical cash flows, not one period after the last cash flow, but on the date of the last cash flow. So if we have a series of cash flows and we want to know the future value as at the date of the last cash flow, then this is a general formula which will give us that. Once again, we're treating each cash flow separately and compounding them up to period N. The last cash flow occurs as at period N and therefore does not need to be compounded. If the cash flows are identical, in this case $10, and the interest rate remains the same throughout the entire series of cash flows, then we call this series of cash flows an annuity. We could still calculate the future value of this annuity by compounding each cash flow separately. So the first cash flow is compounded for 3 periods, the second for 2 periods, the third for 1 period, and the last one doesn't need to be compounded at all. However, we have a shortcut that will allow us to calculate the future value of an annuity no matter how many cash flows there are. Once again, it's important to note that what we have here is an ordinary annuity because the cash flows occur at the end of each period of the annuity. It is also possible to calculate the future value of an annuity due, but that is beyond the scope of this subject. This is the formula for the future value of an annuity, where the future value is as at the end of the annuity, when the last payment is made. The variables have the same meaning as in the previous formula. C is the constant cash flow, where the first cash flow occurs 1 period in the future at the end of the first period of the annuity. R is the interest rate per period, and N is the number of periods.